Hello class, this is the beginning of the videos for the Unit 7 flipbook. This is a flipbook on similarity. We're going to go ahead and start with section number 1, the top flap of section number 1. And this section is labeled ratio and proportions. And if you could, on the very top of this section, please write the essential question, which is, how do I use ratios and proportions to solve problems? And in this unit you're going to be using ratios and proportions, and I wanted to do a review. We'll review this also in class just to remind you about these. You've probably seen them before, but I'm going to go over the properties with you because a lot of the parts of this Unit 7 are very difficult if you do not understand how to deal with ratios and proportions. So how do I use ratios and proportions to solve problems? First thing we have to do is define some things. Let's go ahead and define what a ratio is. So a ratio is a fraction that expresses the relationship between two numbers. So basically a ratio is just a fraction that expresses the relationship between two numbers. And below this definition, we have a sentence here that says the ratio of A to B is the fraction A over B. So when you hear a ratio 1 to 5, 6 to 12, 7 to 2, 5 to 1, basically that 2 means that you're going to put the A value, or the first number, in the numerator, and the second number in the denominator. So the ratio of A to B is A over B. It could also be written like this, A colon B. So this also means A to B. So when you see these letters or numbers written in class, you should not be saying A colon B or AB. You should be able to say A to B, or A over B means A to B. So let's take a look at a ratio. Now most ratios are very easy. They're just one number over another, like I mentioned, 1 to 5, 5 to 3, 7 to 2. But every once in a while you're going to get a ratio that has units in it, and if the units are the same on top and bottom of the ratio, they just cancel each other out and they really don't do anything. But sometimes you're going to have a ratio where the unit of measure on the top and bottom is going to be different. And when you see this, if I asked you what the ratio of this ratio was, you can't say 6 to 18. If you wrote this is just, Mr. Z, this is just 6 to 18, you would actually get it wrong. Because this is 6 feet to 18 inches, but we can't just say 6 to 18 because the unit of measure is different on top and bottom. But we can convert this to a ratio without units. And the way we do that is, oops, gotta get that back. The way we do that is, we're going to go ahead and multiply this times a fraction, another fraction. But this fraction is going to be equal to 1. And if we multiply anything by 1, we know that it doesn't change our final answer. But in this case, our value of 1 is going to be look real different. Let's take a look at this. What if I wrote here 12 inches over 12 inches? I think you'd all agree that 12 inches over 12 inches, that is just equal to 1. But we also know that 12 inches is the same as 1 foot. So what if, instead of writing 12 inches on the bottom, we instead wrote 1 foot? Now, do you see, class, that this 12 inches over 1 foot, that's still just equal to 1? Because 12 inches is the same as 1 foot. They're just different units of measure. Now the cool part about this is that when we write this fraction like this and we multiply our original ratio by this, because feet is found in the top of this fraction and the bottom of this fraction, it can cancel out. And because inches is found in the top of this fraction and the bottom of this fraction, they can be canceled out. And so now we're left with two fractions that all you have to do is multiply them together. When you multiply fractions, remember, you multiply across. This is 6 times 12. That is 72. And 18 times 1 is 18. And this is a ratio. Now we have a ratio that's 72 to 18. That is the correct ratio without units. That's the same ratio as this one, only now it doesn't have units. And we could actually simplify that. If we look at these two, let me see, it looks like 18 goes into 72 4 times. So 72 divided by 18 is 4. And 18 divided by 18 is 1. This ratio is actually just 4 over 1. And we could actually write that also, if you want to put this in the margin, we can write this as 4 to 1. Actually, I'll put it, let's see, how about if we make this a little bit smaller? I'll still circle this, 4 to 1. And it doesn't look very good. Let's try to fix that, 4 to 1. And we can write this as 4 to 1. That would also be the correctly written ratio. So this ratio is not 6 to 18. When we convert the units of measure so they cancel each other out, we end up with a 4 to 1 ratio. So this is a little information about how to deal with ratios that have different units of measure. Let's take a look at the next column. What's a proportion? A proportion is an equation which tells us that two ratios are equal. This is something we're going to be using a lot when we're dealing with this unit called similarity. An equation which tells us that two ratios are equal. So let's take a look at how to deal with this. Let's say that you wrote a proportion 2 over 5, or 2 to 5, is equal to x to 25. The question is, how do you solve for x? How do we find what x is? And there's a neat math trick that we can use here to solve this one. It's called cross product property. The cross product property. Let's write this down here. The cross product property. And the cross product property tells us that if we have two ratios that equal each other, or if we have a proportion, let's just use variables here. If A over B is equal to C over D, then we can rewrite this as A times D is equal to B times C. We can actually get rid of the fractions and change it into a normal multiplication problem. Now, I can go through some Algebra 1 steps with you to show you how this is possible, but for now, you just need to know that this proportion can be rewritten by moving the D over to the A and moving the B over to the C. So the way we do this on paper to keep track of it is, we'll go ahead and do this. How do I find the value of x if I have this proportion? Well, the 25 can go with the 2, and the 5 can go with the x. So I'm going to go ahead and write here, this is going to be 2 times 25 is equal to 5 times x. So notice I took this proportion and I rewrote it as a multiplication problem. These two equations are identical. All we did was use a little bit of algebra trick to get it to look a lot easier to deal with. And now let's go ahead and find x. 20 times 25 is 50, so 50 equals 5x. Now we can divide both sides by 5. If you divide the right side by 5, you just get x. If you divide the left side by 5, you get 50 divided by 5 is 10. We just figured out that in this case, x is equal to 10. This is a skill you absolutely have to have in this unit to be able to deal with proportions. I'm fixing that equal sign. So there is a quick background on proportions. Last column is, let's take a look at how ratios and proportions show up in actual problems. Change my pen color here. John shoots 150 times in the entire basketball season. He makes 25 of those shots. What is the ratio of made shots to total shots? So I've got made to total. Remember from our ratios, A to B is A over B. So in this case, made to total means I'm going to put the made shots on top, which means he made 25 here. I'm putting his total shots on bottom, 150. There is the ratio of made shots to total shots. Now we can simplify that. Looks like 25, looks like 150 is divisible by 25. 150 divided by 25 is 6. 25 divided by 25 is 1. So the ratio of made shots to total shots is actually 1 over 6. Or you could write this as 1:6, which means 1 to 6. Or you could actually just write it as 1 to 6. Any one of these answers would be acceptable, so I'll circle all of them. 1 to 6, 1 over 6, or you could write 1 and use a colon to represent the word 2. So that's how we can use ratios in a word problem. Let's take a look at the next one. James made 72 free throws out of 84. Trevor made the same ratio of free throws as James. If Trevor made 60 free throws, how many did he shoot? So, the same ratio of free throws as James. So James made 72 out of 84. So I can write that as a ratio 72 out of 84. And now we're going to set that equal to another ratio, and that's going to be Trevor's ratio. Now, he made 60 free throws, so because we put 72 on top, that's the number that James made, we've got to put the number that Trevor made also on the top of the fraction. That's going to be 60. And the thing we don't know is, how many shots did he take? How many times did he shoot? All right, let's go ahead and do our cross product. So we're going to do 72 times x. Remember, this is going to go to here. So this is going to be 72 times x is equal to 84 is going to travel over to the 60. It's going to be 84 times 60. All right, let's go ahead and do 84 times 60, which is 5,040. So we've got 72x is equal to 5,040. And now we can see algebra 1, divide both sides by 72. So 72x divided by 72 is just x. 5,040 divided by 72 is 70. So if Trevor has the same ratio of made shots to attempts, or same ratio of made free throws to shot free throws as James, that means if he made 60 free throws, he had to have shot 70. That would mean that we would check our ratios here. He'd have the same ratio as Trevor. And let's check that out real quick. If you do, let's take a look at this. If you take 72, I'm going to move this over here. If you take 72 and divide it by 84, you're going to get, take a look at that, 0.857. So I'll put a little note here on this one. Let's just make a quick note, 0.857. Let's take a look now, and we'll do Trevor's free throws. He shot 60 divided by, he made 60 divided by 70 attempts. And his ratio, take a look, 0.857, the exact same percent as James did. So that just verified that x is equal to 70. So last thing I'll put on here is you want to write this as a word answer. So the way you'd answer it is Trevor shot 70 times. All right, that's the end of video 1.